Welcome back. In this video, I'm going to talk about how to write custom decorators in Angular. So let's get started now. Before jumping into writing custom decorators, let's go through the basics first. What exactly is a decorator? A decorator is simply a function that helps to enhance your code by using a declarative syntax, which is easier to read. We can add decorator to a function, to a class, to a property, and to even on the function parameters. We can categorize decorators into 4 different categories: class decorators, property decorator, method decorator, and parameter decorator. If we take an example of Angular, we have seen @component, @directive, @ng module, and so on for class decorator. For property decorator, we have seen @input, @output. For method, we have seen host listener, host binding, and finally for parameter decorator, we have seen @inject, which we use on services, @optional, and so on. We always start decorator with @ followed by name of the function. So in this case, component, directive, input, output, all of these are functions. This is how we use decorator in our classes. In this case, we have a class called C, and we are adding a decorator called decorator name. The name of the decorator can be anything, and it should be prepended by @. You can pass some data to your functions. This parameter can be anything, and this is our property decorator. Accessory is a property of class C, and @reactive is a property decorator. Likewise, on this class, we have this method called m, and @logged is a function decorator. And finally, we can also have parameter decorator. M is a function, value is a parameter, and this is a parameter decorator. So now let's first go through some of the inbuilt decorator of Angular. For example, we can see ng module. If you look closely here, ng module is simply a function. Our decorator can have some parameters or some data that's required for this decorator. We also called it as metadata, or it can be empty. In case of Angular, we can provide bunch of metadata for ng module. For example, declaration, imports, bootstrap, providers, and so on. With the help of metadata, app module can decide the component that is responsible for bootstrapping the application. We can define the imports and so on. Likewise, if we go on our app component, we have @component. And again, this is a class decorator because this comes just before the class. And it again has bunch of metadata. If we look on this component, we have a property decorator. And property decorator should be added just before the property. We have parameter decorator, which is passed just before the parameter. And finally, let me also show you the method decorator. If you look closely here, valid is a method, and this is the method decorator. And keep in mind that all the decorators should be added just before the function, class, property, or function parameter. I have created few custom decorators in decorators folder. Let me walk you through all of this decorator one by one. I want to start with this decorator called PageAnalytics. Let me open customers component. So let's assume I have a use case where I need to track the number of visitors for this page. One of the options would be to inject the tracking service on this component and then call that service on ng-onInit function. For example, I already have this service called analytics service, and it has this method called track. And this method will make some third-party API call to record the visitor. So one approach is, of course, I can just add that dependency here and call that track function here. And this track function requires one parameter, which is the name of the page. If I refresh the page, then I can see record page on service customer page, which is coming from right here. So this way also I can track the page. But the drawback of this approach is if I want to track other pages, then I need to inject the service on the constructor and then call this track method on ngOnInit lifecycle hook for all the components. So instead of doing this one, we can use Decorator. So let me undo my code again. I can achieve the same thing using Decorator. So if you notice here, I have called this PageAnalytics, which is prepended by @ sign. And I mentioned earlier that Decorator can have some metadata, or this function can have some inputs or parameters, or it cannot have anything. In this case, I'm not providing any parameter to this function, so there is no any small bracket. So if we go and look on this function, there's nothing. It's just function. And one thing to notice is that decorators are executed during the runtime. And when it's invoked on this function, the argument that we get is constructor. So before I explain what this constructor is, let me show you whether we are seeing this text or not. If you notice here, we are seeing this constructor right here, and then only we can see ngOnInit, which is coming from here. That also means we can manipulate any method on this class component before that lifecycle hook or any other custom method is triggered. So what this constructor is exactly, I want to walk you through a simple example. Let's say we have a function called animal. It has a property called color, which is red, and I have added a method called run, and it returns a string. If I print this animal, we get this function. We call this as constructor function, and all the constructor function has this property called prototype. So if I do prototype, we now see this run method and also this constructor, which gets executed when we create a new instance. If you add more methods, all of those methods are accessible from prototype object. So this constructor gives us the customer component function. Keep in mind that classes are simply a syntactic sugar over constructor function. Since JavaScript is not purely object-oriented language, we don't have the concept of class. So let me try to print the prototype now. If you look here, now we have access to all the methods that's defined on the component, which is right here. We have destroy, we have scroll, navigate, and so on. All of these can be accessed from the prototype object. That also means I can manipulate any of these methods. My idea now is to do this. What I'm trying to do here is I first got the reference to ngOnInit method, which is this function. And then I'm replacing the same method with a new one here. This is a function. And if your function accepts any arguments, you can provide. In our case, ngOnInit does not require any parameter. Therefore, I'm going to remove this one. Just for the sake of simplicity, we don't need this argument anymore. And my plan is to call that track API call right here. If you see here, we have decorator class, which is coming from here. And then we have track, right? So meaning I can call that service and then make the API call. And after I track the visitor, I can then execute the onInit method. And to execute this method is pretty simple. We can simply call apply or call method, or even we can use bind method. Let me remove this one, it's not required. Let's try to keep it simple. So this is the same function reference that we saved earlier. And I'm going to call the function. And the important thing to note here is the first parameter of apply is the context. we want to make sure the context is the customer's component. It's because when we execute this function, this keyword should point to this object or this component. So this line is very important, right? If you want, you can also call. It's the same thing. There's no change. So everything looks good here. So now let's imagine that you want to pass some data from the component. Since we are using PageAnalytics Decorator in multiple pages, we need to know which pages were tracked. So in that case, I should be able to send some parameter to our decorator. On this parameter, I can send the name of the page. Here I'll say customer page, but we are getting some error now. It's because whenever we are sending any parameter to our decorator, we have to wrap our function with another function, which means we need to copy this code at the very top, and this function now will have page name. This function returns another function, like so. If I save this page now, error should be gone. And let's try to save the page name as well. I'm going to print that page name right here. And we can see the page name right here, which is customer's page. That also means now I can pass this page name on this API call. That way we know which pages were visited by the user. So keep in mind that if you are not passing any parameter, then you only need to have one function. But if you are passing any data to the decorator, then you need to have a function that should return another function. And now finally, how can we inject analytics service in our decorator? It's very simple as well. I already have that implementation with me at the very top, so I'm just going to comment this code out. So the way to inject the service is like this. We can just call injector.create and provide the providers. And after that, we get the instance of analytics service. And finally, we can call the track method here. If we check the console now, we can see record page on service followed by customer page, which is coming from right here. So now you can use the same syntax on all other pages, and then you can pass different parameter for that page. So this syntax is clean and easier to read and understand as well. And as mentioned earlier, this is declarative as well. The main goal of declarative syntax is that we focus on what needs to be done rather than how it should be done. Let's go over to our another class level decorator, and that is called unsubscribe. As we know that whenever we are subscribing to any observable, we get stream of data. But if we navigate to some other pages, we want to make sure that we are closing that stream. And to close that stream, we simply call unsubscribe method. So for example, in this page, I have created a observable here, right here. So we'll be getting some data on interval of 1 second. And I'm saving this subscription on data subscription. Let me first show what this code exactly does. As we can see that in the interval of 1 second, we are getting new data. But let's say if I go to some other pages, we are still getting this data. This is not good. We want to close the stream and release the memory. So one approach would be to go on your ng-on-display lifecycle hook and then call unsubscribe. Let me go back to customer space. We are getting this stream data. If I go back to home page, we are not getting this anymore. So imagine you have to do this kind of thing on many pages. You will be repeating the same thing over again and again. So how can we make this better? So instead of calling this one, what we can do actually is we can create a class level decorator which handles all of these tasks for us. So let me add that decorator as well. one thing I want to share is that we can chain as many as decorators we want. So on this component, we have 3 decorator: component, PageAnalytics, and unsubscribe. So first, let's test this decorator, and then I can walk you through the code of this decorator. Let me save this file. Let's first go on the customer's page again. We are getting this event data, and if I navigate to home page, we are no longer getting that data. So this is working. So let's go back to our unsubscribe method. So this is again class label decorator. Since I'm adding 2 brackets here, our decorator is considered as Decorator Factory. If we don't define these 2 brackets, then it's not the Decorator Factory. And since this is a Decorator Factory, we have to have 2 functions. And on the PageAnalytics, we got this constructor. And it's the same thing here as well. So from the constructor function, I get access to the ngOnDestroy event because we want to unsubscribe on the ngOnDestroy method. And then I created a new ngOnDestroy method. And here I want to unsubscribe from that subscription before I actually call the ngOnDestroy method like we have done before for ngOnInit. So if you look here, I'm basically going through this component, this means this component, and looking for each property. And if we find the property, and if that property has unsubscribe function, then we know that is a subscription and we want to unsubscribe. So for example, let's say we started the loop, it goes through all of these properties, and when it reaches on this line, it finds that data subscription has unsubscribe method. It's because if we look on the subscription, it has this method called unsubscribe. And when it finds this method, we are triggering the same unsubscribe method. And on this loop, we are doing the same thing. We are checking whether the property has unsubscribe function or not. And finally, we just call the ngOnDestroy method. So I think this decorator is very helpful if you are using observable in your project. So now let's go through few method decorators. As we know that Debounce, Throttle are very helpful utilities. So if I want to apply either Throttle or Debounce on our component, how can we do that? Let's assume we have a input text field and then click me. So the current behavior of click me is it helps to toggle this text on and off. And if you see on the console, I'm logging some text here as well. Let me go over to the light switch component, which is here, and the function that gets triggered is this click method. So imagine that you want to add debounce feature on this method. How can we do that? I just need to call the Debounce Decorator, which is defined here. If we look closely on this Debounce Decorator, we again have 2 functions. That means this is a Decorator Factory, because we are using these 2 small brackets, and I can pass some parameter here. Let's say I want to have a time of 2 seconds. So my goal here is if the user clicks multiple times, unless they release the button, we will not be triggering this code. Let me save the file and let me clean the console. So if I click here, I'm not getting any text. If you recall, we were getting some text before on the console. Now if I release, and after some time we are getting this text now, and that time delay is because of this time. Let me do that one more time. I'm clicking here, but we are not getting that toggle clicked message on the console. But I release now, and after 2 seconds I'm getting this text. Right? And we can apply the same thing for the search event. So I have a function called search, which is bound to this input component, and I'm going to add the same debounce feature on this method as well. So let me put this 1000 If I type something here, I'm not getting anything on the console, but once I release my keyboard, I'm getting this message, which is coming exactly from right here, line number 85, right? And this is also pretty simple. So the only difference now is the first function, of course, has the parameter that we pass from this line of code. But on the second function on our class decorator, we only have one parameter, and that parameter was the constructor function. But here we are getting 3 parameters. The first one is the prototype, which we discussed earlier. The second one is the name of the method where the decorator is being added. In our case, it can be clicked or searched. And the final parameter is called descriptor. And this descriptor basically describes the configuration of a property of an object. So in our case, this descriptor is about the search method or clicked method. Let me show you one example of descriptor that way will be more clear about this parameter. I have an object literal called O, and this O object has getHungry method, and it returns I'm hungry. So if I use getOnPropertyDescriptor method on this object and then try to get the configuration data of this property, then let's see what we get. So we get configurable true, enumerable true, and so on. So these are the configuration data of getHungry method. If you look on the value, it means the same method, right? So that also means if I do property descriptor and value and call this function, because this is a function, I should get I'm hungry. Let's go back to our code. Let me try to print something here. Let me add some text here. So now I can see this text being applied here. So the logic here is pretty simple. We first save the reference of the function like we did for ngOnDestroy and ngOnInit before. And then I'm using the actual debounce method from load_s, and then I'm just replacing the same debounce function on the value. And here on this debounce, the first argument is the function that I want to execute after this millisecond, which I'm providing from the component right here. Let me also talk about throttle. It's similar to debounce with only one difference. And the difference is that with throttle, we are invoking some function at some specific interval of time. For example, let me go on the customer's page. Let me clean the console. Let me go here. I have an event called scroll, and this scroll gets triggered a lot of times when I scroll the page. Let me go back to customer's page. Let me scroll the page. We are seeing a lot of scroll. So if I want to prevent this using throttle, then I can do that as well. The goal of throttle is to minimize the events. So let me go over our document scroll, which is right here. And then I want to add throttle decorator on this method. And it requires one parameter. I will pass 1 second. If I scroll the page, we are firing the events on every 1 second, right? And the logic for throttle is again pretty simple, and it is similar to how we implemented Debounce Decorator. And here again, we have 2 functions because this is factory decorator. And the first one is the parameter that we'll be getting from the decorator itself. And the second function has 3 parameters like we saw for debounce. The first one is prototype, name, and descriptor. And we first get the reference of the original function. And then we call the throttle method from load_s. And the first one is the function we want to execute. And the second is the millisecond. The third decorator I want to talk about is timeout. We have seen setTimeout logic in a lot of places in our application. So let's imagine when you click on this click event, you want to fire the event, let's say after 2 seconds, for example. Let me go on the light switch component. Let me try to implement timeout decorator. So instead of adding debounce, let me add timeout. And if I click this button, I'm getting that text after 2 seconds. So if we look on the code, it's pretty simple again. So we have the main function, and then this function returns another function, and we again keep the reference of the original function that we want to execute, and then we are replacing the function with a new function here, and here we are calling the setTimeout, right? And after the expiry of this milliseconds of time, we just execute the same function like we did before. So this decorator is also super helpful, and it's very clean and easy to use. Now let me talk about another decorator called Timer Decorator. So basically, the goal of Timer Decorator is to calculate the time that it took to run a particular function. For example, let's say I have some function here which is called getData, and this function has a loop. Let me remove the comment, and we can see that we are printing all the numbers. So if I want to know how long it took to render the logic of this function, I can simply use the Timer Decorator. And this timer doesn't have any parameters. If we look here, we just have one function. And let me first show you the result. Total time taken is 216 milliseconds, which is coming from this line of code. And all of these parameters are similar to Debounce and Throttle that we discussed earlier. Here we again have the original function that we want to trigger later, and then we again created a new function, and here before executing the function we start this performance.now. This is the native JavaScript feature which gives you the timestamp, and then we run the function. When the function is executed, we again get the timer here. We just find the difference, and that's the total time. This utility function is also super helpful for your project. And finally, I want to talk about one more decorator, which is a property decorator. Imagine we have a property called text, and it has 50 as the value. We have a requirement that the text will never change, so we therefore want to make it read-only. How can we do this? Of course, we can use the read-only property of TypeScript, but if we want to use decorator and want to have the similar feature, then we can use read-only decorator. Let me show you the example first here. I need to be on the customer's page. We should be getting some error here. And we are getting this error which says cannot assign to read-only property text. It's because we are trying to assign a different value for read-only property right here. The way to implement is this logic. We just redefine the same property with writable as false. This way, we cannot write that property. In summary, the main goal of Decorator is to enhance the readability of your code by implementing declarative approach. That's pretty much it. I hope this video helps. If there are any questions, comments, or suggestions, write me down on the comment section below. If you really like my video, please share, subscribe, and like my video. That will help a lot to grow my channel. Thank you very much. See you on the next video. Have a good one. Bye bye.